Have you ever really thought about what happens when you type a web address into your browser and hit enter? You're basically sending a little message out into the world asking for something. Well, today, we're going to build the thing that answers that call. We're building a web server, totally from scratch using just Node.js. Let's get into it.
So you can think of it like this. Every time you go to a website, you're essentially knocking on the computer's door somewhere on the internet. But how does that computer know you're there? How does it know to answer? Well, it can't, unless it's running a special program that's just sitting there waiting for that knock.
In that program, that's our web server. You know, the best analogy I've ever heard for it is a waiter at a restaurant. The waiter's job is to listen for your order, that's the request, and then bring you your food, that's the response. It's this simple back and forth that powers pretty much the entire web.
Okay, so let's dig into that a little bit more. What is a server, really? It sounds like this big, complicated piece of hardware, but at its heart, it's not. It's just a program. A piece of software's one and only job is to listen patiently for someone to connect to it. And to build this listening program, we're not going to need any big, complicated frameworks. Nope. Node.js actually comes with this incredible toolset right out of the box. We're just going to use its built-in HTTP module, which has everything we need to get up and running.
All right, enough talk. Before we write a single line of code, we need to get our workspace ready. You know, like any project, a little bit of organization up front is going to make our lives so much easier in the long run.
And don't worry, this part is super quick. First, just make a new folder for our project. Then, in your terminal, run npm init-y. This little command just whips up a package.json file for us. Think of it like a birth certificate for our project. It keeps track of all the important details. And finally, just create a blank file and call it server.js. That's where all the magic is going to happen.
Okay, now for the fun part. We're diving into the core logic, the absolute brains of our server. This is where we tell our little program how to think, how to act when it finally gets that knock on the door.
So, the very first thing we have to do in our server.js file is bring in our tools. This line right here, const http equals require http, basically tells our program, hey, go grab the built-in HTTP toolkit from Node.js, because we're going to need it.
Now, to really get how this works, you need to meet the two main characters in this story, rec and res. Every single time a request comes in, Node hands us these two objects. Rec is short for request, and it's like the customer's order slip. It has all the details, what URL they want, what browser they're using, everything. And res, for response, that's our empty plate. It's what we're going to use to build our answer and send it back.
So how do we use that res object? Well, the first thing we do is give the browser a thumbs up. We set the status code to 200. This is a universal code on the web that just means, yep, got your request, everything is A-OK. Next, we've got to give the browser a heads up about what we're sending. Is it a picture, a web page? For our simple server, we set the content type header to text/plain. It's like telling the browser, hey, don't expect anything fancy, I'm just sending you some simple text.
And finally, the last and most important step, we actually send the data and we end the conversation. The end dot method does both of those things. It sends our hello world message back to the browser, and then, and this is super important, it closes the connection. This frees up our server to listen for the next person knocking at the door.
Okay, we've written the logic, we've defined the brains. Now for the moment we've been waiting for, flipping the switch and bringing this thing to life. It's time for the launch sequence. You see, a server can't just float around in cyberspace. It needs an address. The hostname, 127.0.0.1, is a special address that always points back to your own computer. It's also called localhost. And the port, 3000, is like a specific apartment number at that address. Together, they give our server a unique spot to listen for those knocks. This one line of code right here is what opens our server for business. We call the .listen method, we give it the port and hostname, and then we pass it this little function. That last part is called a callback. It's like saying, hey, once you're up and running successfully, do me a favor and run this little piece of code for me. It just lets us know it worked. So with our code all saved, it's time to head back to the terminal one last time. All it takes is this one simple command, node server.js. When you hit enter, you're telling Node, okay, take this file, execute it, and start listening. And that right there is the message you've been waiting for. This is the confirmation. Your server is alive. It is actively listening at that address. You can now literally open your web browser, type in that URL, and see your message.
You just talk to your very own server. How cool is that? Okay, a server that only says one thing is a great first step. But let's be honest, it's kind of a one-trick pony. To make it truly useful, we need to teach it how to give different answers depending on what the user is asking for. And this is called routing.
So how do we do that? Well, remember our friend the rec object, the customer's order slip? It has a property on it called URL that tells us the exact path the user is trying to visit. All we have to do is look at that rec.url and use it to decide what to send back.
So our logic can be really simple. If a user asks for the main page, that's just the slash, we send them a welcome message. If they go to /about, they get a totally different message. And for any other URL that we don't recognize, we just tell them, sorry, page not found.
And that last part is so important. Sending a 404 status code when you can't find a page isn't just an error message, it's a critical best practice. It's the server's way of being clear and saying, hey, I looked, but I have no idea what you're asking for. It's incredibly helpful for users, search engines, and all sorts of other web tools.
So there you have it. In just a handful of minutes, we built a program from scratch that listens to the internet, understands requests, and can even give different responses based on a URL. It can say hello, it can give basic directions, the foundation is officially set. So now the only question left is, what are you going to teach it to do next?